Yesterday's lesson focused on modeling integer addition using integer chips, and we discovered a couple of things about adding integers. In fact, we ended the lesson with a song. Pardon my voice again. Same signs add and keep, different signs subtract, and keep the sign of the higher number, then you'll be exact. On your notes, you'll notice you have this chart that says rules to add integers. And it's important to understand that although our song is very handy in remembering some of the rules, it's also important to remember the mathematical definition. When we have integers with the same signs, we're going to actually be adding the absolute values and keeping the common sign. Go ahead and write that in the box if you haven't already. And over here on the example, we're going to work with -3 plus -12. Now, if you think back to the integer chips, we would have 3 red chips plus 12 red chips to represent the 3 negatives and the 12 negatives. All of those red chips would be friends, so we wouldn't have any battling out or zero pairs canceling out. They'd all be friends, so all we would do would be counting them up. But according to our mathematical definition, we need to take the absolute values of both of these signs and add them together. The absolute value of -3 is 3, and the absolute value of -12 is 12, because remember, absolute value is absolutely always positive, since we're referring to the distance from 0 on a number line. Well, when we add 3 and 12 together, we get 15, but that's not quite right, because when I think about my integer chips, yeah, I have 15 chips on the board, but they're 15 red chips, and that is -15. Okay. When we have different signs, you're going to actually be subtracting the absolute value. Remember when we had battles, we ended up with less chips on the board than we began with? That represents the loss of chips, and we use subtraction to represent that loss. Let's go ahead and do -7 plus 5 as an example. And we're going to take those absolute values and we're going to subtract them. Absolute value is absolutely always positive, so this becomes 7 minus 5, which is 2, but we need to keep the sign of the larger absolute value. Since 7 was a larger absolute value and the original number that we were using was negative, the answer is going to be negative. And finally, don't forget that all opposites or additive inverses add up to 0. Go ahead and add underneath opposites that opposites are the same thing as additive inverses, because when you add them together, they inverse each other. They undo each other. Another important way to model integer addition is on our number lines. Let's go ahead and take a look at 7 plus -9. And we are going to model how to add these two integers on a number line. Let's start with 0 in the middle, and I'm going to label a couple of these numbers. Remember, numbers to the right of 0 are always positive. Numbers to the left of 0, I'm going to skip a few, are negative. All right. Anytime we're starting to represent integer addition on a number line, we always want to start with 0. Everything starts at 0. let's read this number sentence. It says we need to go to positive 7, which is 7 spaces to the right of 0. And then we're going to add to that a negative 9. Well, negative 9 means going to the left 9 spaces. But instead of starting at 0 this time, we'd already moved 7 spaces to the right. So we're going to start at 7 and go left 9 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that gets me to ... circle. Negative 2 is my final answer. So 7 plus negative 9 is negative 2. And if we thought about our absolute value definition from above, we'd have the absolute value of 7 is 7. And since these are different signs, we need to subtract. So 7 minus 9, well, that would be negative 2. Okay, let's take a peek at another problem here. And we're going to do, just real quick off to the side, I want to do a negative 4 plus negative 2. I need my force field to separate the addition and the negative. I'll make a small little number line here, and 0 will be off to the right, and negative 1, negative 2, negative 3, negative 4, negative 5. Okay, again, we always start at 0, and let's read this first number of our number sentence. It says negative 4, which means go to the left 4 spaces. And then the second number says we need to go to the left 2 more spaces. Now remember, we're not ending at 0 this time. We ended at negative 4, so we need to go from negative 4 2 more spaces. And we end up at negative 6. So negative 4 plus negative 2 is negative 6. Or same signs, add and keep. So they add 4 and 2, and we keep the negative sign. Okay, I'm going to write a problem down on the practice problem, and then I want you to pause the video, and you try on your own to graph the solution to this problem. Go ahead and pause. All right, let's put 0 in the middle, and I'm going to number a few numbers to either side. I can't get very many of these negative numbers in with my stylus. Okay, we always start at 0, and let's look at this first number in our number sentence, and it is a positive 10, which means we're going to go from 0 to the right 10 spaces. And the second number is saying, hey, we need to go to the left 3 from where we ended at 10. We go to the left because of the negative sign. So I'm going to go left 3 spaces, 1 space, 2 space, 3 spaces, and I ended up at positive 7. 10 plus negative 3 is positive 7. If we think of our song, positive 10 and negative 3 are different signs, so different signs subtract. Well, 10 minus 3 is 7, and keep the sign of the higher number. Since 10 is the higher number, it's a positive, our answer is going to be positive. Example 2 is asking us to evaluate the following expression, A plus B. And we're going to be given different variables or different values for the variables A and B. In this case, A is 5, B is negative 17. Before we even get started, let's take a peek at our values for our variables. if you'll notice, A is positive and B is negative. When we're adding, and we know we're adding because of that addition sign, when we're adding integers, we need to take a peek at the signs. Well, I have one positive and one negative, so these are different signs. That's important when we go ahead and plug in. I'm going to plug in a 5 for my A, or substitute in, plus force field, negative 17 in for B. Well, these are different signs, so I need to subtract. I'm going to go over here and think 17 minus 5 is 12. And I need to keep the sign of the higher number. And since the negative 17 has a higher number, that means that there are going to be more negative soldiers that survive, and negative 12 would be our answer. I'm going to write down a practice problem, and then I want you to pause the video and try it on your own. The expression is C plus D for C equals negative 8 and D equals negative 21. Go ahead and pause it. All right, C and D are both negative. If we think back to our song, same signs, add and keep. But before we even do any of that, let's just go ahead and substitute in our variables. C is negative 8 plus force field. D is negative 21. Like I said before, both of those numbers are negatives. If I were to lay out the chips, the integer chips, I'd have 8 red soldiers plus another 21 soldiers. Well, they're all friends, so we're going to do same signs, add and keep. 8 plus 21 is 29. Keep the negative sign. My answer is negative 29. We have a problem-solving situation here where Cody made deposits of $45, $18, and $27 into his checking account. He then wrote checks for $21 and $93. Write an expression to show the change in Cody's account. Then we need to simplify it. We have a couple of key words here. Deposit. Deposit is when you're adding money to your account. So it makes sense that 45, 18, and 27 would all be adding into Cody's account. After he added all that money, after he made those deposits, he then wrote checks. Well, when you're writing checks, you're taking away money from your account. So 21 and 93 would be negative numbers. We need to use the U-pick strategy for problem solving. And what it means is understand, pick a strategy, implement that strategy, and conclude. In other words, what's your answer in a full sentence? Here, what we're going to actually be doing is integer addition. That's the problem that's what the problem is asking us to do. And through integer addition, we need to know how much Cody has left. My strategy here is just to work it out. Let's start with the first 3 situations where he deposited money. So he deposited the $45, the $18, and the $27 into his account. And after that, he took away, so he added a negative $21, that's his check, and then he added another negative 93 since he was writing another check. When you have more than one integer addition or subtraction, your rules follow from PEMDAS. You do 2 at a time, going from left to right, as long as the only signs you have are either addition or subtraction. Let's take it one step at a time. So 45 plus 18 is 63. And I'm going to do, just rewrite every problem, every number down so I don't get it confused. Okay, 63 plus 27 is 90. I have 90 plus negative 21. 90 plus negative 21. Well, that's a positive plus a negative, so different sign subtract. That would be 69 plus negative 93. And then the final step would be to do 69 plus negative 93. Different sign subtract. So that leaves us 24, but we need to keep the sign of the higher number. And since negative 93 is the higher number, my answer is negative 24. What this means is, after all of this, his balance actually goes down. Goes down or decreases by $24. Hopefully Cody had some money in his account before he deposited those checks, because he ended up spending more than he deposited and he would have gone into debt. Well, that does it for this lesson. Check back in for the next video on integer subtraction.